Hello, today we will learn about reflection and mirrors. And we have in this video, there are four topics I'm covering. Number one, law of reflection. Number two, the difference between specular and diffuse reflection. Number three, images formed by a plane mirrors. And number four, properties of these images. Now let's go. So here is the first topic, law of reflection. It is very simple. Angle of incidence equal angle of reflection. Angle of incidence is sometimes written as I or theta I. Angle of reflection as R or theta R. You can understand law of reflection through this image. This is a mirror. This is the back side. You can see. And this is the normal. The pink line is a normal line. This line actually makes 90-degree angle to the mirror. You can see both sides. It makes 90-degree angle. So we call it normal. Now this ray is the falling ray, which is called incident ray. This is reflected ray, going ray, bouncing ray. Now here this angle, which is in blue color, angle between this line and this line is angle of incidence. It is clear that this angle is made by incident line and the normal. Sometimes students make mistake and they think this angle is angle of incidence, which is wrong. Now, the other angle, which is angle of reflection, is this one, R. This is clearly the angle between the reflected line and the normal. Don't think that this is angle between reflected line and the mirror. No, but this. So students make mistake usually sometimes, as I said before, they think it is angle between incident ray and the mirror. No, this is in red. I have written in the red color so that because it's a wrong, and in the green it is between incident ray and the normal. Similarly, for reflection, angle of reflection, this is the angle between reflected ray and normal, not between reflected ray and mirror. So this image is wrong image, this is the right image. Here is two questions for practice. If the angle of incidence is 35 degree, then what is the angle of reflection? I'm sure many of you can give the answer in a second, in a moment. Now question number two, a ray of light strikes a plane mirror at 23 degree to the normal. What is the angle between the reflected ray and the mirror? Now here is the answer of first question. The angle of incidence is 35 degrees. So what is the angle of reflection? And you know the angle of reflection will be same as angle of incidence. We have the law of incidence which tells us theta I equal theta R. So we have theta I as 35 degree from the question. Sorry for the bad writing. Then the theta r will be, which is angle of reflection, will be 35 is the answer. Next question. A ray of light strikes a plane mirror at 23 degree to the normal. Now let's make a mirror quickly. This is a mirror, for example, and let me make the normal here. This is the normal, and the ray of light strikes at 23 degree to the normal. So this is the incident ray, the falling ray. Make the arrow sign. This angle is 23 degree. And what is the angle between the reflected ray and the mirror? Okay, so this is the reflected ray. We don't want this angle in this question. We want the angle this one. So we know that this will be 23 degree because of the law of reflection. It's angle reflection equal angle incidence equal angle reflection. So theta I equals theta r. So this will be 23. But question asks this angle how much? So because this total is 90 degree. So this will be 90 minus 23. 90 minus 23. So the answer will be 67. Got it? You need to be careful which angle is asked in the question. It is angle between the mirror and incident ray, or incident ray and the normal, or incident ray and the reflected ray. There are some questions when they ask what is the angle between incident ray and the reflected ray. So in that question the angle will be 23 plus 23, 46 degree. Now next topic is difference between the specular and diffuse reflections. So you can see there are two figures, figure A, figure B. One has clear image of the mountain and the other has not so clear image of the mountain. So this is with the clear image. uh, Here the reflection is specular. Specular. Here diffuse. No clear image, no specular reflection, diffuse reflection. Here are two pictures, picture 1, picture 2. Now you understand, I believe, that which one is specular and which one is diffuse. You can see this one is specular. Figure 1 is specular. Figure 2, diffuse. This is this happens with a plane mirror or any plane surface, smooth surface, plane mirror or smooth surface. And this happens with a rough surface. See, the surface is not smooth, it's a rough. Okay. And in the specular reflection, you see the reflected rays are also parallel. If the incident rays are parallel, reflected rays are also parallel. But here, see, incident rays are parallel, but reflected rays are not parallel. See, this is going this side, this is going the other side, and these two lines are meeting, they are not parallel. So this is the difference. Here is a definition. Specular reflection by a smooth surface or plane mirror in which parallel light rays are reflected in parallel. Diffuse, scattered, fuzzy, and produced by a rough surface. Now here is the next topic, images formed in plane mirrors. So this is the plane mirror. A man is standing behind the mirror. Sorry, not behind, in front of the mirror. This is behind and this is in front. He is looking at the image of this bird inside the image, inside the mirror. You can see this bird is, we call it object. The image is image of the bird is image, and you can see how the image is formed. So the rays coming from the bird falling on the mirror is reflected to your eyes, and you think that bird is not here but here. You think because the light you feel that light is coming from here, not from here. Okay, so that's why you see the bird inside the image, sorry, inside the mirror, inside the mirror. Okay, now this is the interesting part of plane mirror. It always makes your image front to back. It means your left hand seems right hand in the mirror. Your left leg seems your right leg. This happens. And this is also called lateral inversion. I repeat, lateral inversion or front to back reversal. Now, here is the summary of properties of plane mirror images. This is first one. Plane mirror always makes virtual image which is not real. You see this image only inside mirror. This image is always erect or upright. See, this is the object and this is the image. You see the direction of the image is similar to the object. See, so we call it upright. Now image distance equals minus object distance. Okay, the distance from mirror to image or object to mirror is equal but with a minus sign because the direction is opposite. See, object is left side but the image is right side. That's why the minus sign here. XO, you know the position of object or distance of object, and XI is image of image distance or the position of the image. I stands for image, O stands for object. Now here next is image height equals object height. You see the height of the object and height of the image is equal. HO equal HI. H stands for height. Lateral inverted or front to back reversed. As we discussed in the previous slide, the image is always laterally inverted or front to back reversed. Thanks for watching.